check this out. This pattern is called beehive. And look at those, dude. That's a beehive nest or something. That's fucking huge, dude. And they're like pretty fine by itself, but just look at this one simple cell. Oh yeah. Oh yeah. Dude, isn't it fucking awesome? And it's symmetrical, dude. Holy shit. In this video we'll build a game of life by John Conway. It's a game about dots, and they can stay alive, they can die, and they can produce more dots based on certain rules. And yeah, it's really cool, and we'll build it in React. I'll leave a link to my GitHub repository if you want to follow along, but basically I have just created a blank template, blank project with npx create React app, and yeah, we need to clean it a bit. So I just started the server with npm start, and as you can see, something is rendering, right? So let's check our project. Okay, so as you can see, there is only everything that we need, no excess files or anything. So what do we have? We have index.html with which is basically just a simple div, right? And it loads index.js, which then renders our game at this root. See, id root, it gets it and it renders it there, our class game of life. And game of life is our simple class where hello world is, and it has CSS, but there is nothing there for the moment. So yeah, and basically that's how hello world works. So I decided that we'll need a simple plan for our project. So what will we need in order to build this game? Okay, so firstly we'll need to render grid. Let's go. Render grid. Second thing is you can actually press on those like cells and spawn live. Spawn live on click. And then we'll need to implement this like living logic. So yeah. Logic. Game logic, let's do it like this. Yeah, and after that we'll just start it and everything will be fine. Okay, so we'll need rows and columns, right? So let's define them. Field. Okay, let's say columns amount will be 10 and rows amount will be 10 too, just for this, you know. Okay, so next we'll need to render it somehow. Let's try to create a function. Render cells. How will it work? Okay, so it will be in a div. Class name game of life cells, and there we should iterate. Oh yeah, dude, firstly we need to store our cells somewhere. So let's just initialize them, you know. So we'll need a constructor for that. If I remember correctly, yeah, this state will need cells, right? Which will be, yeah, and there we should initialize them. This, let's go. Let's create this function. Okay, so how will it work? So we need to create variable cells, right? So let's do it like this. Cells will be, it will be just a two-dimensional Boolean array, you know, and let's fill it. So we'll need a for loop. Let columns column index, let's go, less than game of life field columns amount, and then we'll need second loop with rows row index and less than game of life dot field dot rows amount. Okay, cool. So, and there we should somehow populate it. Okay, let's go. When we enter new column, we will assign cells column index. Let's assign it. Oh my god, this keyboard is strange. Let's assign it just an empty array, okay? And then for each row, we should populate it. Let's go. Cells column index and row index. We'll say false, right? Yeah, but I don't really like false. Let's put in some constant up here. Static cell state. Let's call it like that. It can be either alive, which will be true, or dead, which will be false. Cool. So right now we can just use it like this game of life, cell state, and let's make every cell dead. Okay, so right now we'll create an array, and for each column we'll create a nested array, and then each row will store cell state. So cool. So we have these cells, right? Let's check it. Let's check this out. Is it working? Game of life. Yeah, cool. See? So it's working. So we have like column 0, 1, 2, 3, and then rows. Row column 3, row 1, false, and for each cell we have a state basically. So yeah, let's just render them. So let's go to our render cells function. So there. Oh, okay. Let's try to iterate over our state cells map cell and not cell but rows and column index, right? And there okay, let's just try to render just some simple divs, you know. Class name equals to game of life column. Yep. So let's see if it works. Cool. So as you can see, we have all the columns we need, and then we'll inside of them we'll build a let's move it to the function render column rows and column index. Cool. Yeah, and it will be like this. Yep. What's wrong? Oh. What is, oh, yeah, okay, cool. So yeah. So inside of each column we'll iterate over its rows, right? Rows that map cell state and row index, and we will just render this column. Okay, this cell, I mean, game of life cell. Cool. Yeah, so it should work. Let's see. Yeah, as you can see, we have columns and then we have cells, but we don't have them actually. We only have them in our markup. So yeah, let's fix this. So first of all, we will need actually keys. Let's do it like this. Column index. Okay, and we'll need a key for this too. Key equals to cell column index, and then row index, right? Cool. And so, yep. So let's give them some, like we'll need, right now we have only markup, but we want to see them, you know, so we should add some CSS to this. Okay, so for each cell, I'll do it. Okay, I'll write it. I use Mac, and this is my gaming PC, but whatever. Cell. Let's use 5 and will it work? Oh yeah, and let's create background color black. Cool, so it works somehow. And let's use white, and let's create what's the border? Cool. Okay, so this should work. Cool, yeah, so as you can see, we can see them actually, and let's use like the file for something. Yep, cool. But right now, as you can see, column's not working. Basically, we have all these cells in one cell. Okay, so for that we'll need another style, game of live column. It's this one, which every row is encapsulated in. So let's use display flex direction column. Yeah, this should work. No? Oh yeah, and we'll need and for our cells we need flex display too. Oh shit. Live cells display flex. Yeah, this should do. Oh yeah, cool. So as you can see, right now we have like every column, right? And in every column we have those cells. So yeah, dude, it works perfectly. Yeah, just a lot of cells. So yeah, and right now if like any cell is dead, for example, we should like mark it with different color. You see, black. Okay. Yeah, and let's use this color, dude. So how do we do it? I only know how to do it with the that's the color we need. Okay, so background border, not black, but oh no, I should, okay, CO. Cool. Okay, so now it should be a little bit prettier. Yeah, cool, as you can see. So yeah, let's so yeah, dude, I think that for render grid we're almost done. We just need to, so basically, yeah, if the cell is dead, it should be white, and if it's alive, it should be black. And we don't have this logic right now. So what should we do? We have this cell state there, right? So we should compute, let's compute the different style to this cell. Let's do it like this. Oh shit. But I'm not used to this keyboard. Game of life cell, and let's create a modifier, cell modifier, and cell modifier will be if cell state equals to game of life dot cell state dot dead, then it will be, if it's dead, the modifier will be dead, right? And if it's alive, it will be alive. So yeah, cool. And right now there we can, for each cell alive and dead actually too. Yeah, so those styles will give them, so if it's alive, background color will be black, and if it's dead, it will be white. So yeah, cool. I think this will do. So, but we can click it, but I think that it will do, dude. Just trust me, you know. So yeah. So I think that for our plan, render grid, it works perfectly, and we can actually increment more. Let's create more. Yeah, cool. More columns and more rows, and it works, as you can see. It can work like this, like whatever we want. But yeah. Okay, so basically, first thing is done. Second thing in our plan is to spawn live on click, so that it will click on those like cells, they will change its state. So let's do it. Okay. How do we do it? Okay, so we have this cell rendering thing, right? And let's clean up it a bit. And we'll need on click for this. And if we click this, we should basically remove its cell state, right? So let's use this toggle cell state with a column index and row index. Cool. And let's implement this function. Yep. So what do we need? Let's use it like this. New cells state will be current this state cells. So, and then new cells state at column index and at row index will be, dude, I don't know how to do this on this keyboard. Okay. So basically, let's invert its state, you know? So we get cell on column index and row index, like this one, and then we invert its value. So if it is like alive, it will become dead, and if it's dead, it will become alive. And then let's just set state. State will be equals to new cell state. Cool. So yeah, dude, it should work, I think. Right? Yeah, no bugs intended. Okay, let's go. Yeah, dude, as you can see, it's working, and this, as you can see, this cell, it's changing its modifier, like from alive to dead. So yeah, dude, we did it. It was so simple. Okay, so for our game, we will need some like button which will stop and start the game, because if we will not have it, everything will just die instantly, but we don't want it. So we want to just stop the game, set some life, then like start it, and then it will leave. So yeah, let's create this button. Where will it be? Yeah, it will be on top of our cells. This render start game button. Let's call it like this. And it will be just a button with class name equals to game of life. Start game button. Cool. And its label will be different based on some variable. Cool, right? So we need to store it in our state. So let's go is game running false, and there we just say button label will be if this is game running. If the game is running, then label will be stop, else it will be start. Cool. Yep, and let's use it there. Button label. Cool. If the game is running, we'll say stop, and if it's not, we'll say start. Yeah, cool. So, and on click on this button click, we should create we should change this is game running thing basically. So yeah, let's go. this toggle game state. Okay, let's go. Toggle is game running. Let's call it like this. And what this thing does, it will this set state is game running. This state game running. So it will, okay, 1 second. Okay, so it will just toggle this is game running. So if it is false, it will be true, and if it's true, it will be false. So yeah, and let's see what's the problem. Oh yeah, let's do it like this. So yeah, let's prettify it a little bit. I know it's ugly, but dude, fuck it. Okay, so yeah, let's just see how it works. Start, stop, cool, it works. And so yeah, dude, right now we just need to implement the actual logic. And yeah, let's create a little margin there for our button, start game button. Margin bottom. Let's use 8 pixels. Cool. Not 8, but let's use 6. Okay. Yeah. So cool, dude. Yeah, everything we need right now is to implement the live logic. Okay, so how will it work? So basically every certain like step or every like second or something, some logic should be computed. So yep, let's just do it. So when we initialize our component, our game, we'll set the set interval. We'll set the function which will be called each like second or something with this game tick. Yep. Okay, let's just create leaf. Okay, and it will be called each second. So yeah, cool. So basically, let me explain this again. So when we create our component, we'll set interval to call our leaf function each second, you know, and there we can do whatever. We can just start with console log game tick, and let's see each second it's working. And right now we should somehow compute the next state, and yeah, this will be it basically. So yeah, so what should we do? We should create so basically we need to update cells. So yeah, let's do it. Yep, so each iteration, oh yeah, and if the game is not running, if not this state is game running, then we'll just return, because if game is not running, nothing leaves, you know. So yeah, but else let's compute new cells. Yep, so what do we do there? We just iterate over every cell, right? Column index, game of life field columns amount, and same for rows. Rows amount, cool. And there for each, so basically we iterate over each and every cell, and then we yeah, let's check the wiki actually. So every cell interacts with its 8 neighbors. Okay, so we have cells, we should check those neighbors, and then so basically we need to compute neighbors amount, you know, alive neighbors amount. And if so yeah, see, as you can see, is less than 2 neighbors leave, the cell will die by underpopulation. If 2 or 3 neighbors leave, it will leave. If more than 3 alive neighbors there, it will die by overpopulation. Yep. So basically we need to compute this for each cell. We need to compute neighbors amount. Okay, so let's see. New cell state will be this. New cell state for column index and row index. Yeah, and then we'll do something with this. No? Oh shit. Okay. So yeah. So let's compute this. Let alive neighbors amount will be 0. Yeah. So we'll need. So what do we need? We need to check this state cells. So basically, this is our cell, you know, by column index and row index. And if you want to access its left neighbor, we need to subtract 1 on column index, right? If we want to access right neighbor, we need to plus it. And if we want to access cell on top of it, we can add to row index there. So basically, let's do it like this. So we need to check 8 things. Okay, let's go. Const neighbor offsets. Let's create an array on which we'll iterate. It will consist out of x and y. So let's start with left. Left is -1 and 0. Then -1 and -1. Top left. Yeah, let's call this top left. Top is just 0 and oh no, it's yeah, it's like this, 0 and 1. Just top. Top right will be 1 and 1. Then just right is just 1 and 0. Cool. Bottom right will be 1 and -1. And then just bottom, it's just -1 and 0. Bottom left will be -1, -1. And then, okay, bottom right, bottom, and bottom left. So it's everything we need. 1, 2, 3, 4, 5, 6, 7, 8. Cool. So yeah, and then we'll iterate over those neighbor offsets. For each, no, not like this. In neighbor offsets, offset key. Let's get x offset, y offset will be neighbor offsets key, right? So we have this x offset and y offset, and there we should, yeah, let's get this cell right now. Neighbor state. Let's call it like this. Neighbor state will be these state cells at column index minus x offset. Oh, let's call it plus. Okay. And row index plus y offset. This is neighbor state, and if this neighbor state equals to game of live cell state alive, then we'll increment this counter, alive neighbors amount, you know? Cool. So yeah, this should, so basically, again, how it works, we get our cell by column index and row index, then we iterate over its, like, we create this array of offsets, we iterate over each offset, we get it, we like apply this offset to column and row, and then we check. So basically this thing will give us a neighbor for each direction, and then we check if this state is alive, then we say that it's a live neighbor, yeah, and then we can do shit with this counter, you know. So yeah, so, and we need to include one more thing. It's yeah, we need to include boundaries. So basically, if yeah, let's call it like this, new column offset and new row offset. So basically, if new column offset less than 0 or new column offset more than game of live dot field that columns amount -1, then we just continue, because this is because if this happens, that it's not in our field, and so it's not neighbor, so we don't care about it. And we should do the same for new row offset, right? Less than 0, new row offset, rows amount. Cool. Check boundaries. And then we look at this state. Yeah, okay, so I think that this should work, right? Yes. So yeah, okay, so we computed a live neighbors amount. Yeah, and let's move it to a different function, because that's a lot of like stuff there. Compute a live neighbors amount. Cool. What's the problem? Yeah, let's return it. Return a live neighbors amount. Cool. So yeah, okay, so we have this function which will just compute a live neighbors amount. A live neighbor. Dude, this fucking word neighbor, it's so hard to write for me as Russian. A live neighbors amount. Yeah, okay, so we have this amount, and let's check the wiki. And so right now we should check its if any leaf cell and dead cell. Okay, so if okay, and let's get our current cell state. Current cell state will be the state cells at column index and at row index, right? And then we check if current cell state equals to game of live cell state dot alive, if it's alive, and else it will be a different logic. Okay, so if any leaf cell with fewer than two live neighbors dies by underpopulation. Okay, so if a live neighbors amount less than 2, then return game of live cell state dead, right? Yeah. If any leaf cell with 2 or 3 leaf neighbors leaves. Okay, so else if a live neighbors amount equals to 2 or a live neighbors amount equals to 3, then it leaves. And then any that cells with exactly any leaf cells with more than 3 leaf neighbors dies. Okay, so else if a live neighbors amount more than 3, then it dies again. So yeah, dude, it's hard life of a fucking cell in Game of Life. So yeah, and then any dead cell with exactly 3 leaf neighbor becomes a leaf cell, as by reproduction. Okay, so basically, those 3 cells, those 3 neighbors, like, create a new cell. Okay, so if our cell is dead, then we check if alive neighbors amount equals to 3, then we spawn it. Cool. Yeah, and if we'll not entering any of those conditions, we just return dead, right? Compute new cell state. Okay, so I think that it's the right algorithm. So now, as we have this state, we need to actually update our like cells variable, right? So let's create a new one. Const new cells will be equal to an array, and then there this set state cells new cells. Cool. And there new cells at column index will be equal to this one, and then yeah, and then let's just use this new cell state in our new cell. New cells column index at row index will be equal to this new state. So yeah, so this function will iterate over every cell, compute that new state, and then we just update our cells variable with it. So yeah, let's see what how we got. Okay, so there are some like simple things, so let's start with them. Yeah, dude, see, this works. Let's try to build a block. Cool. And let's create this one. Okay, the last one. I think it's going to be like this, right? Oh, 3 or 4? Yeah, 3. Yeah, dude. See? So that's Game of Life, dude. Okay, so the code is finished. So let's just clean up a bit and let's just test. Let's just test the shit out of it, dude. So right now, this is our Game of Life, dude. Just 200 lines of code, and yeah, we rendered the grid, spawned live on click, and we can implement, and the game logic is implemented. So basically, yeah, that's it, dude. Okay, let's go testing. Let's make some tests. So I just got any accelerators, and yeah, dude, it works super cool. Look at this, it's like blowing or something. Okay, dude, just look at this. I have 6 beehives and I have a glider gun. This thing produces gliders. And so let's see. Check this out. This pattern is called beehive. And look at those, dude. That's a beehive nest or something. That's fucking huge, dude. And they're like pretty fine by itself, but just look at this one simple cell. Oh yeah. Oh yeah. Dude, isn't it fucking awesome? And it's symmetrical, dude. Holy shit. Holy shit, dude. Oh my god, that's awesome. That's like fractals in math. Fuck yeah. So thanks for watching, and I'll build some more stuff. I mean, fun stuff like this in the near future. So yeah, bye.